Hi, welcome to Unit 6, Day 2. This is molar mass in Day 3 preview. In Part 1, we're going to introduce you to the molar mass. So in the last class, we were introduced to the mole. And remember, a mole represents 6.02 times 10 to the 23 things, and that number is also known as Avogadro's number. So for example, if you have a sac containing 1 mole of carbon, you would have 6.02 times 10 to the 23 carbon atoms. If, on the other hand, you had half of that bag that contain a half a mole of carbon, you would have half that value, half of Avogadro's number, so you'd have 3.01 times 10 to the 23 carbon atoms. And then, of course, if you had 2 moles of carbon, you would have double that number, so double Avogadro's number, which would be 12.04 times 10 to the 23, or we can just sort of simplify that to 1.20 times 10 to the 24 carbon atoms. Now, we also learned that the mole is the central unit of measurement for amount, and they're super important for that reason. So remember that all key amounts like volume of a gas, or the number of atoms or molecules, or the mass can all be converted to and from moles, as shown by the mole map. We also learned that coefficients in balanced chemical equation are molar coefficients. So if you look at a balanced chemical equation, which is sort of like our recipe in chemistry, the coefficients tell you the amounts in moles. Now, although the reaction recipe, also known as the balanced chemical equation, lists the amounts of the reactants and the products in moles by molar coefficients, when measuring amounts of reactants or products in the lab, a chemist often weighs or gets the masses of these substances to measure the amounts. So we don't actually count out the number of atoms or measure the moles, we actually measure the mass in a lab. So with that being said, a chemist needs a way that they need something that they can use to convert from the mass to moles and vice versa. And that thing that converts from mass to moles and vice versa is the molar mass. So in today's lesson, we're going to learn about the molar mass, what it is, and how to calculate it. And then we're also going to preview next lesson, which is where we actually will do those conversions, converting from mass to moles, etc., using dimensional analysis. So let's talk about what a molar mass is. A molar mass is equal to the mass of 1 mole of a substance. And the unit for molar mass, because it's equal to is the mass equal to 1 mole of a substance, is grams per mole. So for example, if you had a mole of carbon and you put it on a scale, the weight that would show up on the scale is 12.01 grams. And that's because the molar mass of carbon is 12.01 grams per mole. Now, how would you know that? So you wouldn't know that just off the top of your head per se. Well, you can get that information from the periodic table. You know that decimal number in the periodic table that we've been avoiding for the first half of this class, that average atomic mass, right? That's equivalent to the molar mass. So if you look on a periodic table and you look for that decimal number, so here's carbon, 12.01, that tells you the molar mass of carbon is 12.01 grams per mole. Now, what about molecules? Let's say you had a molecule like water, H2O. So water is made up of more than one atom. And if you take a mole of water and you put it on the scale would read 18.016 grams. And since a mole of water weighs 18.016 grams, you know the molar mass of water is 18.016 grams. But since a molecule like water is made up of more than one atom, how do you get that from the periodic table? You don't see an H2O block on the periodic table. Well, in that case, you actually have to calculate it. And you would calculate it by adding up the average atomic masses of all the elements in the molecule. So in the case of water, it has 2 hydrogens, so you would add up those average atomic masses. And it has 1 oxygen, so you would add that as well. And that's how you get to the 18.016 grams. All right, so in this section, we learned that the moles, which is a reminder that the moles are the central unit for measuring amount. And in a lab, however, chemists don't measure moles, but they measure the mass. So therefore, chemists need something that can convert from mass to moles and vice versa, and that thing is the molar mass. Now, the molar mass is equal to the mass of 1 mole of a substance. So equals to the molar mass of 1 mole of a substance. I had a typo, I just corrected that there. And the units for molar mass are grams per mole, which is written as G/mol. And just so you know, mol is how you write the units for mole. So in the next video, part 2, you're going to practice calculating the molar masses. And you're going to start with a couple of basic examples. Then you're going to see some examples where there are parentheses in the chemical formula, and you're going to learn how to deal with those. And then finally, you'll look at an example of a hydrate. And hydrates are ionic compounds that have waters attached to them. And this hydrate here, for example, is actually Epsom salt. So Epsom salt is magnesium sulfate with 7 waters attached to it. Some ionic compounds just absorb water, and they have a certain ratio of water that they like to have. After you complete the practice, watching the practice video and doing the practice and then taking the exit ticket, then you're going to move on to part 3. And part 3 is a very short preview. It's a really quick play pause it with 2 easy questions, and it's graded for completion. So but that will really set you up for tomorrow's lesson. All right, that's it for this video, folks. Have a quality day.